Hi, I'm Justin Zupank, head of the Asphalt Compaction Development Team at Volvo Construction Equipment, and I'm here today to talk to you about the CX01 concept unit. CX01 stands for Compaction Experimental Unit Number 1, and this is a machine that we developed as we start to look forward into the future. What could compaction look like? We had a few main areas we wanted to address with this concept, the first of which being make the environment better for our operators. The second, we wanted to reduce fuel consumption and reduce engine emissions. And the third, we wanted to make the final customer more productive. So let's take a look at the machine. The unit is a hybrid. On this side of the machine, we have a 1.7 liter diesel engine. The diesel engine is coupled to a 20 kilowatt generator, and the only purpose of the engine is to spin that generator. The generator in turn provides charge to our capacitors. As we move to the other side of the unit, we have two ultra capacitors. These are 48 volt ultra capacitors, and they're taking that charge from the generator, and then they're powering the motors. We have three 14 kilowatt electric motors, one to drive the left half of the drum shell, one to drive the right half of the drum shell, and one to drive the eccentrics for the vibration system. The motors themselves are capable of running strictly off the capacitors if we have enough charge, or if you need to recharge the capacitors, then the engine can be turned back on and fully recharge the capacitors. So this is an experimental unit. We wanted to try a few different technologies, and we're pretty excited about the learnings that we're able to obtain from things like the capacitors and the motors, and then start to look at applying these to other products in the future.
What about the autonomous system? That's not yet fully in development at this point?
Currently this unit is remote control, and we've been able to run this around our facilities doing various types of testing, and our plans are to come back and add an autonomous system to this. We envision these machines to be capable of either type of operation in the field, and we're really looking at the bigger benefit being multiple machines running together. If you're on a larger job site, you might be able to run 2, 3, 4, 5, or even 6 of these machines together versus multiple operators per unit. Now you have one operator who might be able to oversee a fleet of these units and really become more productive.
And that really makes a difference on a job site when there's such a shortage of available workers.
Absolutely, especially in these times now when we have a limited amount of operators available, and sometimes it's tough to put operators in an environment like a compactor. You're dealing with vibration, you're dealing with long hours, the typical environmental concerns that are out there. But now we're able to remove that person from this harsher environment and give them a little bit better, more comfortable office to work within. So the motors, for example, we're able to look at that from what we were using on the loaders and the excavators, but something like the ultra capacitors, we don't use those on any products today. You might find those more commonly in the automotive sector, but for us it was a learning. We wanted to gather the experience about the charge time, the discharge time, and just really understand how it could benefit us on future machines.
So what's next in terms of the R&D with this machine?
For this particular machine, we want to look at upgrading the autonomous system. We want to look at continuing to increase the runtime. And that's going to be a big factor for our customers. Can they get out there and run as much time as they have with a diesel machine? And we want to continue looking for ways to do that.